Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Crystalline Entity, and it's by Icy Fruit. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. We have digits in a circle indicates the number of times that digit appears in either a circle or a square. So, for example, if you have 9 in a circle, that means it appears 9 times in a circle or a square. And that implies all the way down to 1, obviously. 9 down to 1. So, yeah, that should tell you something. Okay, anyways, we also have digits along an arrow sum to the digit in the attached circle. So digits along an arrow, so it's basically typical arrow Sudoku. So these two digits must sum to this. So as an example, you could have something like, whoa, what's going on? Looks like these settings are all funky here. Sorry, you're not seeing this, but... Anyways, as an example, if this was 3 and 5, this would have to be an 8, because these two digits must add up to that digit there. Let me check my settings. I don't know what's going on. Is it advanced? I'd already solved. Huh. This is weird. It looks like some... I don't know. This looks different. I'm not sure what it is about this. I think the lettering was turned off. That's weird. Anyways. Let's just continue. That's all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's count up the number of squares and circles in this puzzle. I'm guessing it's 45. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. 31. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That adds up to 47. That can't be right. Huh. Let me count this again. 1, 2, 3... Okay, let's just listen, yeah. Let's count the... Well, We're gonna mark every non-square and circle. Unless I'm misunderstanding the rule set. There's no way you can have that many digits accounted for. Right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. It is. It's 47. how does that work? Oh. That means certain things cannot be in a circle. Oh, that's fascinating. Okay. I wasn't thinking about that. But you could leave certain things outside of circles, right? And then that you can have more than that did. So you could have a. Huh. Interesting. So if you leave a certain digit outside of a circle, you could have more than that digit in the squares, right? Fascinating. Okay. And you have to have that because it's 47 digits. So you can't have all the digits in a circle. You have to have a digit appear not in any circles, but appear in a greater amount of squares. Huh. That's fascinating. Okay. So all the circles we're going to mark, I don't know, green, and all the squares we're going to mark as red so that we can easily see what we're dealing with, right? Um, hmm. 47 of these. Okay, so huh. This is kind of mind-blowing. Dang. The arrows with two unique digits on them have to be 3 through 9, obviously, right? 3 through 9. 3 through 9, 3 through 9, 3 through 9, and 3 through 9. Hmm. There are at least 6 digits in circles. There may be more, but we don't know if there are more. Huh. There cannot be all 9. That's all we know. We know all 9 cannot be in this in the circles. And those extra ones have to be within squares. At least a couple, right? To get to 47 in circles or squares, right? Because right. Hold up. Okay, in circles, you could have 6 of the same digits in circles here. That's possible. Hmm. These digits are obviously 1 through 8. These digits are 1 through 8. These digits are 1 through 8. And these digits are 1 through 8. What does that mean? We have 47 circles and squares. That means 9 in box 5 has to be in a circle or square. How many extras can you have in squares is kind of a question, right? You could have something here. So 1 out of these 3, and then this one. So that's 1 at most, 2, 3 with 4. Ooh, what are the possibilities here? We have at least 6 digits in circles. You cannot have all 9. You could have 7 potentially, or 8. Even 8 works too. You cannot have 9. What does that mean? I'm not sure right now. In columns 3 and 8, we have 2 which are not in those columns, and they're different digits, but that doesn't really change much, right? Uh, 6 in that row, 6 in that column. There's 5 in that column. 5 circles. 6 in this row, 6 in this row. Can these all be the same? Is kind of a question, right? Kind of, yeah. Doesn't seem to be any real restrictions there. Hmm. Can 9 not be in a circle? Is kind of a question, right? Yes, as long as something else is too, right? Because 9 can only be in 9 squares or circles. And so it doesn't matter if it's in a circle or a square, it can only fulfill up to 9. It could be less. That's possible. You could have less than 9 all in squares. Actually, I don't think that's possible. Okay, so 9 has to be in a circle? Not necessarily. You could have... How many? Okay, yeah, so how many digits can be in squares? Unique digits. So obviously you could have that one. Okay, so we're gonna mark those with 9. So this can't be 9. This is unique in that row. That would be then unique in that row, which could be unique in that row and that column. Then you could have, you only have one of those two. You have one of those two. This can't be. So Okay, so there's 1, 2, 3, 4, 5, and 6. So 6 is possible, I think. That's it. You can have, yeah, 6 unique digits added, right? So that could be 1, 2, 3, 4, 5, or 6, adding to the possible numbers of possible in those digits. Oh, how many? Yeah, how many circles do we have again? We have one. This is 6 plus 4 is 10, 15. Another 6 is 21. Plus 4 is 25. 31. 31 circles. That means you have to have at least 5 unique digits. Okay, so that's not helpful. um, right, we already know there's 6 unique digits. Hmm. Uh, there is. That's interesting. Hmm. There is a at least a circle or square in every row and column. This is a unique one. And it's a square, which is interesting. Not that interesting, but it's, there's 2 here's and they're both squares. There's 3 here and they're all squares. There's 5 here and they're all squares. There's 5 here and there's all squares. Huh. There's 2 here and there's all squares. Hmm. Heck, you don't even have to necessarily have all digits be in circles or squares. So that's not a restriction either. Um, right. So if 9 does not appear in a circle, it has to be just in squares. And it would only be 6 at most. Because there's only 6 rows worth of squares. So it would basically decrease the number you would have from 47, 45 would go down to 42 possible ones, not including, so there has to be another digit which increases it by 5 at least. So it would have to be 3 or 2 digits going up, a combined amount of 5. Huh. Huh. We have 31 circles and 16 squares. Hmm. The squares are in all 9 boxes. That's not helpful. They're in all 9, or they're in 8 out of the 9 rows. Sorry, columns. They're in 6 out of the 9 rows. Does that tell us anything? Not particularly. Hmm. Okay, if 9 is in a circle, where does it have to be? 9 would have to be here, because that's the only digit that's in a circle or square in column 8. So none of these could be 9. None of these could be 9. 9 would have to be one of these two. 9 would have to be one of these two, and this couldn't be 9. So 9 would have to be here. So 9 could not be any of these, could not be any of these or these. So 9 is one of those 4. 9 would be one of these 4. 9 is one of those 2. The only 9 possible in column 1... Oh, that's a square, sorry. No, it could be any of these circles too. It cannot be here or here, so the 9 in column 2 would have to be here. So this could not be 9. Okay. But we're not guaranteed that 9 is in a circle, so that's one issue. So this would be 9, 9, 9. Nine would be in one of these circles. 9 would be in one of these circles. 9 could be in the square or circles. It could be in any of these circles, any of the squares or circles. These squares or circles. Huh. And we don't have any other restrictions. That's interesting. Say 8 and 9 are in circles. Where is 8 have to be? 8 cannot be in column 8. That means 8, the missing 8 that's not in a circle or square has to be in column 8. That means in columns 1 through 7 and 9, the 8 has to be in one of those columns. So that means this is an 8. This 8 means this can't be 8, so that has to be an 8. There could be an 8 here, so that's not necessarily an 8. Column 1, that's fine. Column 3, it's fine. Column... There's a lot of possibilities. So yeah, we have that. I think those are the only restrictions, really. Yeah. Because 8 could be any of... Yeah. There's a lot of choices for columns in everything else. Okay. For columns... Okay, so assume 7, 8, and 9 are all in circles. That means 7 has to be in 7 circles or squares. Therefore, 7, the missing 7s are missing in column 8 and column 5. Therefore, there must be a 7 in all the other columns, so this would have to be a 7. But I think that's the only one that we really have, right? Yeah. What about 6s? Oh, that's interesting. Is it? Maybe not. Um, huh. Oh, hold up. Let's go a different route. There has to obviously be a digit that's missing from one of the circles. At least one. What does that mean, though? That means in it has to be it can in rows 1, 6, and 9. It has to be in columns 2, 5, and 8 at least. The one at least there's at least one digit missing in the circles. There could be more, but we don't know. But whatever's missing has to be cannot be in the circles. So it must be in rows 1, 6, and 9. It has to be in columns 2, 5, and 8. What that means is it cannot be part of these cells, right? So whatever missing digit is, let's say it's orange, right? It could be here, here, or whatever combination, right? It could be something like, okay, so let's remove the blues. So say the orange could be here, here, and here, or it could be something like here, here, and here. Whichever one it is, the red digits cannot be in the columns 2, 5, and 8. The squares in columns 2, 5, and 8 cannot contain that digit. Um, let's just remove that. Okay. So what does that mean? That means none of these can be that. Okay, so let's say it's something like this, this, and that. Obviously these squares cannot count. These squares cannot count. So these are removed, essentially. These are removed. And these are removed. How many squares can you have, essentially, that in that place? You could have 1, 2. Interesting. So 1 out of these 3. It could be 1, 2. It cannot be either of these. 3, 4, 5 possible ones. So if you had 9 not be part of the circles, you could only have 5 at most. Five nines at most. Okay. How many does that remove? So I think that's 10 total, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So if you had 3 digits which were removed, that means the extra squares you could have would be 10. filled with those digits. And that's guaranteed anyways, period. So you have at most 10 digits extra to add up to the 47, right? Therefore, if you subtract out say you try to subtract out the 9. If you try to subtract out the 9, at minimum, you would have 3, 4, 5, 6, 7, 8. Right? So say these digits 1, 2, and 3, 1, 2, and 9 were not part of circles. Were not in circles. If that were the case, that accounts for 12. You can only make up the squares of 10. So you're actually subtracting 12 and gaining 10, period. Which is not possible, right? Because the rest must be in circles. So the rest has to be in circles. You're at most adding 10 and you're subtracting out 12. So 9 has to be in a circle from that. I think the same with 8. So if you subtract, yeah, same thing with 8, 7, I think also 6, right? If you have 1, 2, and 6 that are missing. If you have 6, oh, wait, no. 7 works. Okay, so 9 by itself, you can only gain 9 more. So that only works adding 2. You can only add 2 from the 9. You can't add anything from the 9 by itself. If you add 9 and 1, you can only gain 10 digits. So that's a net 0. 9, 1, and 2, you still gain 10 digits at most from that. So you subtract out 9, 1, 2, you're guaranteed 3, 4, 5, 6, 7, 8, right? That's guaranteed in squares and circles. You can only get an additional, from 1, 2, and 9, an additional 10 digits because of the squares not in columns 2, 5, and 8. Because they have to be, those 3 digits have to be in 2, 5, and 8. So 9, no matter what, has to be in a circle. 8 is the same way. 8 by itself, you can only be in 9 squares overall because of the 9 digits. And bingo. So since 9 has to be in a circle, that means 9 has to be in this column. And it has to be in that square specifically. So, because of that, 8 by itself cannot be... Well, first of all, 8 could be technically in 9 of the squares by itself. But that's only a difference of 1 gained, right? So you could... assuming 8 is the only digit not in a circle... That means the rest of the circles add up to however many digits there are, which is 45 minus 8, which is 37. 37 plus 9 would be 46, which is too small to account for all the circles and squares. Now, if we try to have 8 and 1, you are guaranteed a 2, 3, 4, 5, 6, 7, 9. So that's subtracting 1 and 8 from 45. That's 36. You only get 10 more because 1 and 8 have to be in columns 2, 5, and 8. Guaranteed. And they can't be in any of the square parts because they have to be in rows 1, 6, and 9. So because of that, you lose 9, so it's 36. Plus 10 at most, because those are the only squares outside of rows 2, 5, and 8. So that would give you 46 again. And the same problem if you have 1, 2, and 8. That subtracts out 11. So 45 minus 11 is 34. 34 plus 10 is 44. And that's not enough to add up to all the circles and squares. So 8 is guaranteed to have to be in every... this guarantees this is 9. 8 has to be guaranteed as a circle. So because of that, 8 has to be in all the columns and rows except for this one, right? So this must be an 8. This can't be 8 or, is this 8? I don't know. Oh, not, where's 9? 9 cannot be either of these two in column 2, so it must be here. So that's 9. 8 can't be here. 8 must be here then. And that's all that's guaranteed. So this can no longer be 9. These can't be 8. You can't have an 8 anywhere outside of a circle or square except for column 8 for 8. Now the question is 7. Can 7 by itself add more digits if it's the only digit not in a circle? And the answer is no. Because... oh, but it could be with 1 and 7. 1 and 7 could work. 7 by itself can't, because you can't have 7... you can only have 6 squares by itself. So the gain by the 7 of itself only works if you add 2 more digits, right? But you can't, because the squares only can only be 6. You can only have 6 squares total that are the same digit. But 1 and 7 does work. Because if you have 1 and 7 essentially not be in the circles, if you have 1 and 7 not be in the circles, you could gain 10 total squares. But all of these squares would have to be 1 and 7, interestingly enough, that are outside of columns 2, 5, and 8. So 1 and 7 could work. 1, 2, and 7 does not work. Because, again, you subtract 10, but you only gain 10. So that adds up to 45. Six by itself also does not work. So we could have 1 and 7 be essentially the numbers outside circles. You could have 1 and 6, that also works, and then you just need to gain 2. So that would be 9 out of the 1 and 6 possibilities. Let's see. So this can't be 9, which means this can't be 8. These cannot be 8 here. That's interesting. Because of the 8 in the box. So the thing is, that's interesting. Either this is 7, and none of these... it has to be like 1, 6, or 1, 5, or even just 1 by itself, which you gain 2. Or I guess, so it would be 3 1s in a square. Or you have a 1, 7 pair in all of the rest of the cells outside. Oh, outside of column 2, 5, and 8. But we have 3 squares here in column 9. So, and it cannot be just a 1, 7 pair here. So we are guaranteed 7 has to be in a circle also, right? To get those 2 extra values to add up to 47 from 45, we lose 1 and 7, so that's 8. We must gain 10. So we have to gain all the squares to be 1 and 7. So this is 1 and 7, 1 and 7, 1, 7. 1, that's not in columns 2, 5, and 8. But they all have to be 1, 7. And therefore, in column 9, that would not work. Because you have 3 digits all requiring to be 1 and 7, which is 2 digits there. So that's not possible. So 7, even 1, 7, does not work. So we know 7 has to be in a circle also. And can't be in column. Okay, so this can't be 8 here because of the 8 in the column. So 7 cannot appear in a circle or square in columns 8 and 5. That means in column 2, it has to be in a circle or square in that column. Therefore, this can't be 7 here. I think that's it. Okay. So you could have 1, 6, and that satisfies everything potentially just by being in squares. So this can't be 7. We have 1 through 6 in the rest of column 2. 1 through 7 in the rest of column 5, and then 1 through 8 in the rest of column 8. So that's not that helpful there. Okay. So 6 could work with 1. So what you have is you have a 1, 6, 1, 6 pair here, adding up to... So these 6 are already taken care of in... so that means we are left with the other 10, which are not in columns 2, 5, and 8. So it could be 1, 6, unfortunately. So 1, 6, you need only 9 of them to satisfy 1, 6. So it would have to be 1, 6 here, 1, 6 here, 1, 6 here. This couldn't be 1, 6. So 1, 6 here, 1, 6 here, 1, 6 here, 1, 6 here. And then 1, 6 here, 1, 6 here. And that would be 9 digits accounted for. We have, again, 2, 3, 4, 5 in circles, 7, 8, 9 in circles. So that would add up to 14 plus 24, 38. And we have these 9 cells in squares where they're not also in circles, right? So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So then you have 38 plus 9, which adds up to 47. And that would satisfy all the circles and squares. So 6 does not have to be in a circle. And then now we just have to figure this out. So this is a little... I don't know. Okay, I'm going to pause because I need to go to the bathroom. We'll be right back. Okay, I'm back. Let's continue. So, we have 31 circles. We already accounted for 6 digits, which have to be in boxes. Or squares. Sorry, not boxes. Squares. That means, and they have to be in the circle. Okay. So we're removing the 1, 6. I'm curious where else do we want to attack then. So this cannot be 9 here. This can't be an 8, obviously, because of the 8 in the row. Okay, so there must be... So where are the 8s? Where are the 9s? 9 has to be in one of these 4 circles. It has to be in one of these 4 areas. Same with these. Same with these. It's not here. It could be any of these 4 and any of these... Oops. Any of these 4. 8 in boxes 1, 2, 4, 5, and 7, 8 have to be in circles or squares. Because we're missing an 8. The 8 that's not in a circle or square is in column 8. So that means 8 has to also be one of these 4, one of these 4, one of these 4, and one of these 3. 7 is missing in columns 5 and 8. Actually, 8 could be here. So this could be 8. Right, 8 could be one of those. Okay. Okay. 8, sorry, where's 7? 7 is missing in columns 5 and 8. So that means it has to be in all digits in box 1 and 7. We already have 1 and 4. So it must be one of these 4 and one of these 4 here. So this cannot be 7 here. That's interesting. This is 1 through 6, because these digits, again, have to be 1 through 6. So this cannot be 8 or 9. This is 1 through 6, because it's the same digit as that. Oh, it's a circle. That's interesting. Huh. What does that tell us? I'm not sure. I forgot that it's a circle, though. So 8 and 9 both have to be here. The rest we're not sure about. Can you ever have 3 unique digits? Maybe? One, 2, 6 does not work. Because you can, again, only have 10 more. 1, 2, 5 could potentially work. It's a little bit hairy. Actually, 1, 2, 5 cannot work. Because one of these would have to be 1, 2, or 5. And then we have 3 digits here, one of which is not 1, 2, or 5. So it would not gain 10 necessary. So the only ones... Same with this with 1, 3, 4. So it would have to be either 1, 2, 3 or 1, 2, 4 if you have 3 unique digits that are not circles. Interesting. So this is 1 through 6 here. Because, and this is 1 through 6 here. Actually, all of row 5. Oh, that's interesting. All of row 5 is 1 through 6. Huh. Okay, maybe not that interesting, but... oh, this could be 7. So this could be 7 technically, too. 7 could be any of these two. 9 does still have to be one of these 4. Because it must be in a circle or square. We can't have 8 or 9 here because it matches that digit there. 8 or 9 could be any of these circles or squares. These digits are 1 through 7. Um, hmm. Okay. Hmm. You still could have a single digit. That's not in a circle. Hmm. Okay, that doesn't tell us much. This is 1 through 7, 1 through 7, 1 through 7. This can't be 7. 1 through 6. Yeesh. Hmm. Hmm. There are 6 circles and call and squares in box 6. There's 6 circles and squares in box 3. There's only 4 circles and squares in box 9. What does that mean? I'm not really sure. 4, 6, 6. That's 16. Hmm. Oh, in column. Hmm. Huh. Hmm. Hmm. Maybe I should try the 1-6 combinations, right? So say we try 1-6. Because that's the only one that works for 6. 6 can't be by itself. Because you can only get up to 6 other unique digits adding together. So that would make it 45, which is too small for the number of circles and squares. If you have 1 and 6, that does work. As long as you have 9, 1, and 6s. So this is the one that has 2 sets of 3, right? If you try to make this 1-6 and that 1-6 with a pair, the problem is you are guaranteed to lose 2 digits if that's the case. So if this were 1-6, obviously one of these would have to be 1-6, so you're losing 1 then. But then one of these also be 1-6. So therefore, if you tried 1-6 by itself, this is 1-6, 1-6, 1-6. All of these are 1 and 6. Okay, so 7 and 8 cannot be here. 7 and 8 can't. This could be many things. So 1 and 6 cannot be here, 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 or here. So far, that's okay. This can't be 1 or 6. One and 6 cannot be in a circle. So this would be 2, 3, 4, 5. This couldn't be 1 or 6 because of the 1 or 6 in the column. Okay. Where would the 8 be in row 8? It's outside of a square. And we know in column 8, the 8 also has to be outside a square. Therefore, this would guarantee this is an 8, because that's the only place where you can lose an 8 in a circle and a square, and we know it's guaranteed to be in row 8 and column 8 if this is 1 and 6 as a pair. So this must be 8 and 1. Therefore, this is 9. This can't be 1. This is 6, which makes this 1, not 4. Ew, that can't be 9. This is 9. This is 6, which makes this 1. This 1 eliminates 1 here. Ah, and then you have then you fail as a 1-6 pair. Bingo. So because this 1-6 pair would eliminate all possibilities for 1 and 6 in the rest of row 1. So therefore, that shows you cannot have 1-6 as... So 6 can never be also outside of a circle. So 6 also has to be in a circle. So 6 has to be in all... 6 has to be in all circles except for columns 2, 5, and 8. So 6 cannot be here, here, or here. And it cannot be here. 6 can't be here, or here, or here, or here, or here. Because again, it cannot be in a circle or square in 2, 5, and 8. Therefore, it has to be in 6. The other 6 columns, it has to be in the row, in the circle or square. But we don't know any of the boxes it's required to be in a circle or square. Rows aren't as limited. Boxes aren't as limited. So we still don't know about 7, 8, or 9. So we guaranteed to have at least a 5. At maximum. You could have 1, 5. That's interesting. If this is not 8, what does that guarantee? That guarantees there's no 8 in row 8, and there's no 8 in row column 8. But we need 8 8s. So therefore, this must be an 8, which makes this a 1, which makes that 9. So assuming this is not 8 here, that means this has to be 8 here. 1 has to be here. What does that imply? I don't know. Hmm. Okay, another thing I thought of. If you have a single digit, okay, if you have a single digit that's outside, it would have had to have been 8. But the problem is that can only fill out 9 of the cells, so that can never work. Because every other single digit has to be in that amount in a circle or square. That already accounts for everything. So it has to be exactly adding up to 10. So it has to add up to 10. The other digits have to add up that are not in. Right. The other digits which are not within. Okay. Yeah. So to explain this, every digit that's in a circle is in the circle or square in that exact amount. That means the other digits have to fulfill the rest of that amount. If it's a single digit, it's only 8, which can be because there are 10 other squares, or squares that are not accounted for. Is that right? Right, because you can only have 1 1, you can only have 2 2s, you can only have 3 3s, etc., etc. So that means the 8 would have to go up to a 10. Or the 7 would have to go up to a 9. Basically, that's not true. Yeah, well, that is true. Basically, every set of digits essentially has to work that way, right? So, if you have a single digit that's removed, that must account for all the extra digits. So if you have a 4, let's say you have a 6 that's missing. Well, obviously 6 can't work. If you have a 5 that's missing, actually let's work with 6. If you have a 6 that's missing, that means you have to have 8 sixes left over in squares. But you can only have 1, 2, 3, 1, 2, 3, 4, 5. I think it's just 5 actually now. Right? One out of these two. One out of. You could have 2 here. So one out of these 3. Well, let's say it's here. If you have 1. Okay, so you could have potentially 1 here. That eliminates these possibilities. Obviously, that's no longer valid. This is no longer valid. You could have 1 here, so 1 out of these 2. 1 out of these 2, and 1 out of these 2. Can you ever have 5? That's actually a good question. If you have a single digit, okay, so can you ever have 5? Say, okay, so this would eliminate here, here, but you could have, so you could have 1 of these 2, 1 out of these 3, so 2 potentially here. If you have 1 here and 1 here, okay, so out of these 3 rows, I think you can only have 2. Out of these, you can only have one. Out of these, you can only have one. So I think it's 4 at max, right? Because if you have, say you try to have one here and one, if you had one here, that means you have to have one here out of these two, which is, so that's 4. So you can only have, if you're the single digit, you can have at most 4 other unique digits added. So that means 1 and 2 can be the only single digits possible. If you have 2 digits, you have to add 2 again, exactly 2. So if you can add up to 8 at most, but you can't have 1 6, you can't have 2 6 because we've shown that this doesn't work. Actually, maybe 2 6 does. No, because you can't have. The reason why 1 6 was working here is you cannot have 3 1 6s here, right? You can't account for all 10 squares. One of them is going to be a different digit. So you could add up to 7. It's the same problem here if you have 3 digits. If you have 3 digits here, this digit has to be one of those that's missing. So it cannot be in any of these 3 cells. So you get at most 9 digits or 9 extra squares possible for 3 digits. Therefore, that's why it could be 1 2 3 or 1 2 4 as the digits that are not remaining. I think that still works. Right? As long as this digit is different than these two. Or what, yeah, it has to be, this digit would be essentially either that one or this one or whatever, right? It just couldn't be any of these 3. So we're missing 1 digit here. So it's 1 2 3 1 2 4. If you're 1 or 2, you can gain 4 unique digits. So 1 would gain 3 unique digits. 2 would basically go up to 4. 3 could not work by itself. How about pairs? So, okay, for single digits, it's 1 and 2 specifically. Those are the only ones that work. Because you can only gain up to 4 unique digits in squares. And you'll lose... if you lose 3, you're already... that will only add up to 46. If you have 3 unique digits, it could be 1 2 3 adding up to 6, in which you gain 8, or 1 2 4, in which you gain 9. And the reason why you can't have 10 is because in box 3, one of these 3 has to be, one of the 3 digits has to be in this cell specifically. So you're not going to gain that digit in one of the boxes. So we have 1 or 2, or 1 2 3, or 1 2 4. Okay. Hmm. What about 2 digits? We've shown that 1 6 does not work. If you have 1 5, you have to gain 8 digits. The problem is there's a lot of combinations, right? You could have anything from 1 2 to technically 3 5. No, you can't have 3 5. Anything that adds up to 9, you could have. Sorry. Anything that adds up to 7, which is 2 less than 9, which is the 9 maximum you can have for 2 digits. 9 is also the maximum you could have for 3 digits. 4 is the maximum you can have for 1 digit that you're losing, that's not in a circle. So it's not 4 is the max, 9 is the max, 9 is the max. So it's 2 and 5, or 3 and 4 potentially could work. Okay. Let's try 1, 2, 4 as the digits that are not in circles. What does that give us? So this is 1, 2, 4. It's a 1, 2, 4 triplet in columns 2, 4, and 6, or rows 1, 6, and 9. Right? Okay. That means in the 3 can only... Well, first of all, we have to gain 7. Sorry, we have to gain 9 digits. So, again, we're missing this 1, 2, or 4 in box 3. So we have to have 1, 2, 4 everywhere else in the squares. So this is 1, 2, 4, 1, 2, 4, 1, 2, 4, 1, 2, 4, 1, 2, 4 here. This can't be 3, 5, or 6. This is also 1, 2, 4, and this is 1, 2, 4 here. That means where is the 8 in row 8 or column 8? It has to be here. So this is 8, which makes this not, this has to be 1. This is 9. So this cannot be 1, and this can't be 1 here. Why is that 1, 2, 4? That actually could be any of the digits. So, basically anything that's not in box 3 would be removed. That's 1, 2, 4. Okay, so this one could be any of these. This has to be 1, 2, 4. This is not 3, 5, 6. This is 1, 2, 4. This is 1, 2, 4. 1, 2, 4 here. This can't be 3, 5, or 6. We cannot have 1, 2, 4 in the rest of box 3. And this, okay, so this would have to be 8 then. That would be 8 and 1, so this is 9. 1 cannot be here. 1 cannot be here. This can't be 1 either. Where is the 6? That's interesting. Aha! We have a contradiction. 6 cannot be any of these cells. Because, again, these have to be leftover 1, 2, and 4. This cannot be 6 because 6, except for columns 2, 5, and 8, has to be in a circle or a square. Actually, this can't be 6 either? Yes, that can't be 6 either. Oh, that actually leads to a lot of things, potentially. Okay, so we don't even have to do that right now. Okay. Right, I missed that 6. This can't be 6 either, right? Actually, this can't be 7. Because, again, 6 is missing from a circle or square in columns 2, 5, and 8. In the rest of the columns, it has to be in a circle or square. That means we can remove in columns 1, 3, 4, 6, 7, or 9 any 6 that's not in a circle. Where is the 6 in row... Where is the 6 in row 5? Can't be here because, again, 6 has to be in a circle in columns 1, circle or square in columns 1, 3, 4, 6, 7, or 9. So if it's not a square or a circle, it can't be a 6. So the 6 has to be in one of these two squares. which means one of these squares has to be a 6. We still have 3 digits here, which cannot be a pair just by themselves. So that gives us 8 squares, which we can add. So for 2 digits, you can only add up to 6, which is 2 minus 8, because you can only gain up to 8 squares. Because of that, you can only gain up to 8 squares. You can only lose 6 or fewer. So therefore, because you can only have 2 out of these 3 if you're missing 2. Obviously, 6 could be here, so this could be the other one that you're missing. So that could still be 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And that would satisfy for 2 digits. And that's the same for 3 digits, right? You're still missing this digit here as a third digit. That if you have 3 digits not within circles, this digit cannot be in these cells, and one of these has to be a 6. So, and that's not from 1, 2, 3, or 1, 2, or 4. So you're missing one digit, one square here, and then one square here. That's 2 squares that you're missing. So that means you can have at most 8 gained. So if it's 6 digits, if it's 3 digits not within circles, it specifically has to be 1, 2, 3. If it's 2 digits that's missing, it specifically has to be add up to 6 at most. Did we try 1 and 5? I don't know if we did. Maybe? Hard to say. It can't be 1. Is it? Yes, it can't be 1. Okay, so if you have 2 pairs, if you have 2 digits not in circles, say it's like 1 in something else. The problem is, well, okay, it's only 1 and 5 that fails. Because we're missing a 6 here. So 6 is one of the squares here. So this has to be 6 or this is 6, right? Therefore, 6 is one of these two. We're missing a square here. We're missing one of them here because this is a set of 3 digits. It cannot be both these two. So it has to be this one being 1. So say like we had 1, 5 here. And one of these is 1, 5. That forces this to be 1, 5. Oh, it doesn't have to be that one. This would have to be 1, 5. This would be 1, 5, 1, 5, and 1, 5. And then we'd have 1, 5, or 6 here, 1, 5, or 6 here, 1, 5, or something here, 1, 5, or something here. Again, 8 could not be here, because again, we need 1, 2, 3, 4, 5, 6, 1 out of these two, 7, 1 out of these two, 8. So this would guarantee to be 8, because we don't have an 8 in a cell, in a square, in a circle, in row 8 and column 8. So this is 1, 5. This has to be 1. This is 9. This cannot be 1. This is 5. This can't be 1 or 5. So that's actually okay so far. This 5 eliminates 5 here, so this is 1. This 1 eliminates 1 here, so it's 5, which makes this 1. One of these is 6 with 1 or 5. This can't be 1 or 5, so this must be the other 1 or 5. Ah! We have a problem. I don't know if this is the case with 1, if this is specifically with 1 and 5. Where are the 1 and 5s in rows 1, 6, and 9? It cannot be here because of the 1, 5 in the box. It cannot be here because of the 1, 5 pair in that box. So they would both have to be in row 6. Because again, they do not appear in row 1. They can't appear here. They can't appear here in rows 1, 6, and 9. And they have to avoid being in a circle. So they would both have to show up here. That doesn't work. So 1 and 5 doesn't work. 1 and 4 potentially could. 2 and 4 potentially could, because the reason why this doesn't work is because of the 8-1 issue, right? 2 and 4 could work because if this is 8-1, if this is not 8, that forces this to be 8 and 1 here. Maybe we should wonder if this, what happens if this is not 8? Huh. Interesting. Anyways, let's continue. That's actually interesting. This can't be 7. Yeah. 6 has to be one of those two. Okay. What else did... Okay, yeah. That was when we were trying out things. What happens if it's 1, 2, 3? That is a good question. So then, if it's 1, 2, 3, we have... This is 1, 2, 3, 1, 2, 3, 1, 2, 3. These must be 1, 2, 3. Because 1, 2, and 3 are not within circles. This can't be 1, 2, 3. These can't be 1, 2, or 3. So this is 4, 5, 6. That's fine. This can't be 1, 2, or 3. This can't be 1, 2, or 3. We have to have, again, we're missing 1 digit here and 1 digit here. So the rest of the squares have to be 1, 2, and 3 to add up. So this is not 1, 4, 5, 6, 7. This is not 4, 5, 6, 7. This is 1, 2, or 3. This cannot be 8. Again, we have to have this problem. So this is 8. This is 1. This can't be 1. This can't be 1. This can't be 1, 2, or 3. It's 4, 5 here. One of these is 1, 2, or 3. One of these two cannot be 1, 2, or 3. This can't be 1. This can't be 1. This can't be 3. This looks okay so far. Oh, this can't be 1, 2, or 3 in column... in column 5. This is 4, 5, 6, 7 in the rest of column 8 also. This obviously can't be 3 anymore. This can't be 3. Can't be 4. It has to be at least 4 with... Okay, so this cannot be 5 or 4 because of... To add up, because cannot be 9. And that would be 4, 5 plus added with 4, 5 to add up to 9 if this is 4, 5. So this is 1, 2, 3. We have a 1, 2, 3 triplet in box 5, which eliminates 1, 2, 3 in the rest of the box. That's 4, 5. We have a 4, 5, 4, 5 pair in row 5. So this can't be 4, 5. This is 1, 2, 3. This is 1, 2, 3, or 6. This is 1, 2, 3, or 6. This can't be 1 here because of the 1 in the row. This is a 9. Which means neither of these can be 9. That doesn't tell us very much. So far this is looking okay. Hmm. Ah, we have a contradiction. In row 3, where are 1, 2, and 3? Well, one can be here, one can be here, but the rest have to be 4, 5, 6, 7 that are not in circles. So you would have to have a 1, 2, or 3 in a circle here. So we've shown now you cannot have 1, 2, 3 as the digits that are not in circles. Okay, so it's only 1 digit or 2 digits. We don't know which. It cannot be 1, 5. We've shown that that leads to a contradiction. It could, if it's a single digit, it's 1 or 2. Hmm. Okay, so if it's a single digit, it's 1 or 2, and you're gaining uh, one, 3 ones somewhere, or 4 twos somewhere. 2, 4 seems like it works. 4 is the largest digit you can have in it, so it's 1 through 4 that you gain. But the problem is we don't know which ones it can be. So any combination of from 2, 4 down to 1, 2 seems like it works. Um, hmm. Hmm. What else do we have? So we've shown 3 digits cannot be outside of the circles. If it's 2 digits, it could start with 2 and 4. That seems like it works fine. Let's try that. So this would be, I'm pretty sure that works because the issue is that basically this not being an 8 forces this to be 8, 1, and then we seem to have contradictions with the 1s. So 2 and 4, again, one out of these is 2 and 4. This is 2 and 4 with something. This has to be a 2 or 4. This is, again, 2, 4, or 6. This is 2, 4, or 6. We don't know about that. This is 2 or 4. This is 2 or 4. This is 2 or 4. So we have, and this is 2 or 4. So we have one extra 2 or 4. 2, 3. So 1 here. 2, 3, 4, 5, 6. And then 2 out of these 4. Oh, that's interesting. That means 2 out of these 4 have to be, 2 out of these 3 have to be 2 and 4, which means this cannot be 2 and 4. That would guarantee this was 2 and 4, and this is 2 and 4, right? To not be in circles, because it can't be here. Therefore, this is 2 and 4, and this is 2 and 4. This 2, 4 means this has to be 8, which makes this 1. That's a 9, so that's okay so far. This can't be 1. No 1, no 1. 9 cannot be here. 9's one of those two. That doesn't tell us much. This can't be 1. This can't be 1. This can't be 2 or 4. These cannot be 2 or 4 here because of the 2, 4 pair in the row. This can't be 2 or 4 here or here because of the 2 or 4 None of these could be 2 or 4. because one of these two has to be a 2 or 4. This 2, 4, 2, 4 pair. Okay, yeah. 2, 4 cannot be in the circle, so this could be 1, 3, 5, 6. That's fine. So far, this is looking fine. This obviously can't be 4. 4 cannot be in circles at all. Okay. 2 and 4 cannot appear outside of row 1, 6, or 9 in columns 2, 5, and 8, right? Because it must be twice in column 2 in 1, 5, or 9, twice in column 5 in row 1, 5, 6, or 9, and it has to be in 6 and 9 in row 1 or 2, right? Sorry, in column 8. Because it has to fill the 2, 4 here in this box, so this can't be 2 or 4. This 2 or 4 cannot be here, so it's either here or here. And either here or here in column 6 and 9. So again, this cannot be 2 or 4 here. This cannot be 2 or 4 here. Oh wait, no, this could be 2 or 4 here. This can't be 2 or 4. Oh! We have a contradiction. We have a contradiction. Okay. Because I think that works for any 2-digit number. That's interesting. Okay, fascinating. So what does that mean? Okay. So for every... So say we had any 2 digits not in... For any 2 digits not in the circle. Where can they be in rows 1, 6, and... Actually, in columns 2, 5, and 8? If you have one that's here, say, and you have another one... Like, where is it in rows 6 and 9? One of them has to be here, and the other one has to be here. Guaranteed. That means orange cannot be here, here, and here in row 4 specifically, right? Because orange, if you have 2, one of them has to be in 1, 6, or 9. In column 2, it has to be in 1, 6, or 9, right? Because there's only 3 spaces, columns 2, column 5, and column 8, for those rows where it can appear. So it'll appear one of these 3, one of these 3, and one of these 3. Because of that, it cannot appear anywhere else in columns 2, 5, and 8. So, what does that mean? That means that for row 4 specifically, those digits which are not in the circles cannot appear in 2, 5, and 8 because we know they have to be in columns 2, 5, and 8 and 4, 1, row 6, and row 9 because there's only 3 spaces for it. So they will occupy those 3 columns in those specific rows. So because of that, we know if we try to have 2 depth cells which are not in circles, in row 4, they can't appear in 2, 5, and 8. And there's only one space in row 4, which is not a circle. So you have only one digit, which is not in a circle. Every other digit must be in a circle because of that. That is fascinating, actually. I should have been able to pick that up earlier, but I don't know why I wasn't able to. So that must match whatever the digit is, it must be that cell. So this cannot be a 9. This has to be 1 or 2. Because again, 1 or 2 can only... You can only have one unique digit in squares 4 times at most. And so it's 1 or 2 here. That's fascinating, actually. So 2 can appear 4 times, 1 can appear 3 times. We just don't know which one it is. So this digit does not match that one. So this could be an 8. So we have a single digit that's not in a circle. That's interesting. And it's 1 or 2. It's this digit specifically. So I guess I'll mark that as blue. So none of these can be blue here. This can't be blue. Blue has to be one of these 2 here. So blue is one of these 2. Blue has to be one of these 3. And then blue has to be one of these 3. So it needs to avoid circles in the rest of... Okay, so it cannot be in columns 2, 5, and 8. It can't be in columns 4 anymore, but that's not really that restrictive. In 2, 5, and 8, it has to match one of the squares because the rest are all circles. So it matches one of these, so it's in one of these 2 cells. It cannot be here. So in row 8, it will not match a square. Okay, that's fine. In row 5, it could match one of them. 2, 5, and 8 here. So it's so the blue in row 3 has to be one of these 2. That's interesting. So we're guaranteed it matches one of these. We don't know if it matches here. Can it be 2 is kind of the question, right? No 2, 4, 5, or 8. So it's one of those. It's here. It could be both of these. So it's one of... Okay. Say it's here, right? Then it's not there. It cannot be here. It cannot be either of these 2. So say we're trying... I don't know. Say we had 2. Well, okay. So yeah, say it's here. if it's here, that means this can't be it. Let's say we're saying it's 2. Actually, let's just mark it. So say this is 2, this is 2. That means 2 cannot be here. We have to have 4 available. It's one of these two. And then it's one of these two. That seems possible. Hmm. Hmm. So we have all the digits available from 3 through 9 in circles. They all have to be in circles. The only digit that's not is 1 or 2. That's not in a circle. We still don't know what that is. That doesn't seem to do very much. Hmm. Hmm. Ah, what about if we look at columns? Where can these digits be in columns? Or where can the single digit actually be in columns? Okay, so let's not mark the rows. Where can they be in columns? In column 1, okay, let's mark. I think it's 1, 3. If we look at 1, 3, 4, 6, 7, and 9, where can it be? Okay, so we know it's here, obviously. So then here, here, and here in column 1. Here, here, and here. Oh, this one also. In column 3. 4 is already taken care of. 6 has to be here, 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 or here in column 6. Column 7 has to be here, here, or these two. And column 9 can be here, here, or here. That's 5 columns we've taken. And I think that's 5 rows, right? 1, 2. Well, yeah, because 2, 5, and 8 are already right. Hmm. Yeah, that's still okay. Can't be here. Because we know it's not the same box. That's still not helpful. Right? It's the same as the rows, essentially, right? Hmm. Hmm. Right. This is 4 here. We have 3 here, which is helpful. We have 3 here, which is not that helpful. We have 4 here again, which is not that helpful. We have 4 here again, which is not that helpful. Hmm. Okay, that's not helpful. Interesting. If this is the blue, that eliminates blue from all of these cells here, here, and here, and along here. That would mean we have access to squares here, here, and here. So that's 3. So this would have to be a 1 if that were the case. So I don't think, well, 2 could still be here, because as long as it's not the digit that's, yeah. Hmm. Fascinating. What are we missing here? So actually, let's start coloring also where 2, 5, and 8 can be in, or where the blue can be in columns. Sorry, rows 1, 6, and 9. It can only be here. Okay, it can't be here. That's interesting. Okay. Hmm. Hmm. Um. Hmm. That's not helpful. Hmm. Hmm. Oh, that's actually interesting. Say this is the blue digit. That means that blue digit cannot be here. It has to be one of these two. That means it can't be here. So the blue digit would have to be here. That would leave that as the blue digit. Okay. Huh. So again, if this is the blue digit, none of these are blue digits. These obviously cannot be blue digits. This can't be a blue digit, and this can't be a blue digit. So one of these two is a blue digit, which means this can't be blue, which forces this to be a blue digit, so this can't be blue. That just leaves these two as blue digits, so this can't be blue. Therefore, this must be the blue digit here. One of these two is a blue digit. One of these three is a blue digit. So we have one of these as a blue digit, guaranteed. That's a blue digit. Still could have both of these be blue digits. We don't know. If this is this, then this is 6, obviously. Okay, that didn't give us anything. Okay, this is not a blue digit, obviously, because that has to be blue digit. Hmm. 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 Okay, so say this is the blue digit. And we remove blue here, here, here. Obviously, it can't be here. So this must be blue here, which means this can't be blue. This can't be blue. So it must be blue here, which means this can't be blue. So this can't be blue here. This can't be blue here or here. So one of these is blue. This can't be blue, so this is blue. So far, it's fine. How many squares is that part of? 1, 2 maybe, and 3 with 4. 3 or 4. Because we're always guaranteed this, right? Unfortunately, that's still... We didn't find a way to limit things. Okay. This is... I don't know what the next step would be, though. What is the next step? So it's definitely one of these two. This doesn't really do very much. We tried it here. That didn't seem to do very much either. We tried it here. That didn't seem to do very much either. How many columns and rows do we have that are almost completely filled with circles and squares? Column 9 has 8 circles and squares. Column 3 has 8 circles and squares. If... No, we don't have it restricted, unfortunately. Column 4... That's interesting, though. Right. Okay. I see something. Okay. Column 3. Actually, let's remove all the blue. Let's remove all the blue. That's throwing me off a little bit. Where are the non-circle and square sets that are columns? In column 1, we have these 3 cells. In column 3, we just have this. In column 4, it's just these. Let's not make it blue. That throw me off. Orange. We're going to make it orange. Actually, let's make it pink. We're going to make it pink. This is pink. This is pink. This is pink. Column 4 is pink and pink here. Column 7 is pink and pink here. Assuming 1 is in a circle. First of all, it's in a circle then, which means it's not in a square at all, because it has to be in a circle to match. Does it have to be? Yes, it has to be in a circle, and it has to be in one. Well, yeah, we don't know where. Assuming 1 is in a column, or 1 is in a circle, it cannot. It has to be in column 3 or 9. It has to be in the circle, in one of those circles. So one of these must be a 1. That eliminates these possibilities as 1. And for columns 1, 4, and 7, where can the 1 be? It only has 2 rows they can be in for those 3 columns. So therefore, it would have to be in another circle or square. So 1 cannot be in a circle. It must be 2 in the circle. So 1 is specifically is the one that's not in a circle. Because of that. I knew it was doing something with the columns, but yeah. So therefore, this is a 1. So this is guaranteed to be 1 here. This is a 1. That eliminates 1 in the rest of any circles. Obviously, 1 cannot be in the rest of that row, column, or box. This cannot be 7 because it adds up to 8 at most. This could still be 2 and 7 here because that could add up to 9. 1 can't be here. So we have 2 other 1s total. So, okay, so using that same logic with this, where are the 2s? Right? 2 can only appear in 2 circles and squares. So, in these columns, where are the 2s, assuming they are not in the circle or squares? It has to be here and here. Here. This would be actually not this. It's this one and this one. In these 5 columns, we only have a 2 not available. Sorry, we only have availability to not be a circle or square in 3 rows. Therefore, in those columns specifically, the 2 has to be in the row in the circle, in the row or square. So, in column 6, you cannot match any of the 2s in a row, in a circle or square, because we already have a 2 all available in either 1, 3, 4, 7, or 9. In one of those columns, sorry, two of those columns, 2 has to be in one of the circles or squares. Because we don't have enough area, enough rows for it to be not in those 5 columns. So in the not in 1, 3, 4, 7, 9, that means in column 6, 2 cannot be in a circle or square. And it can't be in any of the rows that were eliminated. Because those have to have a 2. So this cannot contain a 2. These cannot contain a 2 in column 6. The circles cannot contain 2s. And this cannot be 2. Where is the 2 in column 6 then? It has to be here. So this is 2, which means this can't be 2. This can't be 2, and this can't be 2. This cannot be 2 anymore, which means this can't be 2 here. 2 has to be in a circle somewhere, but we don't know where. It could be another one in a square, so that should be okay. Where is 1? So we need 3 1s total in squares. We don't know where that is. It cannot be here, obviously. All 9 9s must be in a circle square. There must be 8 8s, 7 7s. There's 3 1s, and everything else is the number that it has. So this cannot be a 2, and this cannot be a 2. Because in columns 2, 5, and 8, they have to be essentially not in circle, or not in the circles in 2, 5, and 8. And they can't be in the rows that are needed for the 5 columns, right? And that's rows 2, 5. That's ironically well, maybe not ironically, because the way that you build this, I think you have to basically come up with like some pattern. So rows 2, 5, and 8 are basically where they have to be if they're not in a circle or square. Okay. Okay, this cannot be 3 here. It's at least a 5. This cannot be 3 here. It's at least a 5. Okay. We know 1 has to be one of these 2 here. So this cannot be a 1, right? Because 1 cannot appear in any row, or it cannot appear in columns 2, 5, and 8, except for row 1, row 6, and row 9. So this cannot be 1. This can't be 1. Ah! Bingo, bingo, bingo. Maybe. Hold up. No, this can't be 1, but this still could be 1. Oh, that's not good. Yeah, never mind. Okay, never mind. Thought I had something, didn't really. I was guessing that this could not be an 8, but it could still be 8. Okay, never mind. So again, in columns 2, 5, and 8. Okay, so this can't be 1 or 2. Therefore, this can't be 7. Why can't that be 2? Oh, because except for in the 5 columns, 2 has to be in one of those 5 columns, right? To match either a square or circle or be not in the squares or circles, right? So 1, aside from rows 1, 6, this cannot be 1 here. So aside from rows 1 and 6, oh, that's interesting. This has to have a 1 in it, no matter what. 1 can't be in circles, and it can't, aside from rows 1, 6, and 9, cannot be in columns 2, 5, and 8. So this can't be 1. These can't be 1 because of the 1 here. These can't be 1 because of the circles. This is a 2. So 1 has to be here. So this must be, this cannot add up to 9. This cannot add up to 3 either. It could add to 1, 3 to add up to 4, 1, 4 to add up to 5, etc., all the way up to 8. That's interesting. One has to be one of those. So 2, 5, and 8 cannot have a 1 unless unless it's in row 1, 6, and 9. Okay. Right, that can't be 1. This can't be 1. Okay, so yeah, we should mark the blues again. Oh, this can't be 2. Bingo. Okay, so where is the 1 now in row 3? It cannot be in columns 2, 5, and 8. This is a 2 now. So this has to be a 1 here, which means this cannot be 1 here. Because it can't be in a circle, right? Because 1 is the one that's not in a circle. And it can't be in columns 2, 5, and 8. Well, this 1 means this can't be 1. We have 3 1s in the squares. So no other 1s can be in a square. So this can't be 1 here. So we're marking those. That's a blue. This is blue. This can't be 1. So blue has to be in row 1. It has to be one of those 2. It has to in row 2. It has to be one of those 2. We already have for row 4. Row 5, it cannot be here. So it has to be one of these 2. In row 6, it can't be here, so it's one of these 2. In row 7, it's one of these 2, again, because it can't be 2, 5, 8, and it cannot be part of the circles. In row 8, it's a lot of things. It could be any of these, or this, or this. In row 9, it has to be one of these 3. Okay. So we have all the 1s accounted for in squares. Yeah. Still a little bit, I'm not sure where we're going with this. Okay. Uh, hmm. Hmm. 2 is only in 2 circles or squares, and it's in column 1, 3, 4, 7, or 9. It has to be in a circle, too. Does it? Maybe it doesn't. Could be 2 squares, maybe. Yeah, it could be 2 squares. Hmm. No, it has to be in a. It has to be in a circle. It has to be in a circle. Because, yeah, even if it weren't in a circle, it would still fulfill this criteria, right? But the problem is that, again, the rest of row 4 is circles. That can't be 2, 5, and 8. So it has to fulfill that, at least. Hmm. I don't know how much longer I can go tonight. Hmm. What happens if... Okay, so let's say this is 8 and 1. Let's go back to that, right? If this is 8 and 1, we're assuming this is not 8, right? That means this has to be 8 and 1. This is 9. Obviously, this is not 1, so this has to be a 1 here, which forces 1 to be here. That means 1 has to be here. This can't be 1. This would have to be 1. This would be 1. Ah, and we have a contradiction. Okay. That does help, actually. Okay, there we go. So we're assuming this is not 8. So therefore, where is the 8? Same thing, right? This is 8. This is 1. This is 9. This 1 eliminates 1 here. 1 can't be in the circles. 1 can't be in 2, 5, and 8 unless it's in column in rows 1, 6, and 9. So this must be 1 here. That makes 1 here, right? This 1 eliminates 1 here, so this is 1. This can't be 1, therefore this must be 1, and we have a contradiction. So, we know 8 has to be here. So this is 8. This cannot be 8. 8 cannot be in the rest of this box. And it cannot be these 2 cells. Where is the 8 in box 2? It can only be in a circle, so it's here. So this is 8. That means 8 cannot be here. 8 has to be one of these 2. That doesn't really tell us much. But this can't be 8. Okay. Does that... Okay, so this can't be 8, which means this cannot be 6. It's... Yeah. This can't be 5, because it must add up with 3 to add up to 8 at minimum, which is not allowed. Okay. Actually, can this ever be 1? I think that's the answer is no. Right? If this is 1, that means this can't be 1. This is 1, which means this can't be 1. This can't be 1 here, but this 1 being not being there means this has to be 1 here, which means this is a 1 in both places. So, this can never be 1. Okay, so can this be 1? Probably. Right? If this is 1, say this is 1, that means this can't be 1. Can this be 1? If this is 1, that eliminates 1 here, so that forces 1 to be here. 1 can't be here, so 1 has to be here, 1 has to be here. Therefore, this 1 eliminates 1 here, but it has to be here. And there's a contradiction. So this can't be 1 either. Okay. So 1 has to be one of these 3. Oh, where's the 1 in column? There we go. Where's the 1 in column 3? Can't be a circle, and no more squares are allowed. So it must be here. So this must be the 1, which means this cannot be blue. This cannot be blue. Therefore, the 2 in column 3 has to be in a circle or square, but you could still have a 2 here, so that's fine. 1 cannot be here. This is 1, 2, 1, 3, 1, 4, 1, 5, or 6, so this cannot be an 8. Okay, that doesn't tell us too much, unfortunately. This is 1, which means this can't be blue. And this can't be blue, so this must be the blue, and must be 1. Therefore, this can't be blue. This can't be blue. Where is the blue here? It has to be here. So this can't be blue here, which means this must be blue here. So this is 1. So this cannot be pink. Because that we were looking for. So this can't be 1. It's not blue. Where is the blue in column 2? It must be here. So this is 1 and it's blue. This cannot be the blue. It's not 1. This is the 1 here, and this is 1. So those are all the ones possible. So we can remove the red. Red is not helpful. We can remove blue too, because that's not helpful anyways either. Because we have all the ones now. So now we're going to mark, again, for columns 1, 3, 7, and 9, where are the possibilities for 2? Oh, this can't be 1 here. This is a 1. Okay, whoops. That's a 1. So there's are all the ones. So for 2, for column 1, 3, 4, so in column 3, we know a 2 has to be in a circle or a square. We still don't know where else. Okay, so this can't be 1, obviously. We still don't know where else the 2 could be. 2 could technically be in a circle here, so that's not helpful. This can't be 2. Okay, so this cannot be pink. Oh. 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 Huh. So, where can the 2 be if it's not in columns? If it's not in a circle or square. This cannot be a 2 anymore because that is a 2. So this is the only viable option. These are viable options, and this is viable option. But say this was not a 2. That means there has to be in column 1 and 9, one of the 2's has to be in a circle or a square, right? Because if this is not a 2, the 2 has to be either here or in columns in the circle or squares in columns 1 and 9. We already know 2 is in column 3. That accounts for 2 2s in circles and squares. The rest of them cannot contain a 2 in the circle or square. But this can't be 2. So therefore, in column 4, the 2 would have to be in this square. That would eliminate 2 from being here, and one of the 1 or 9s has a 2 in row 8. So this couldn't be 2. Therefore, we would have to have a third 2 in a circle or square in column 7, and that's not allowed. So this must be a 2 here. Therefore, this can't be 2. 2 is here. 2 cannot be here. So this doesn't act as a pink, right? That does act as a pink. That's why I was coloring the pinks. The 2... So we know... Okay. That's not true. Oof. If, say, there was a 2 in one of the squares here. Well, say it was here. That means this couldn't be 2, and that couldn't be 2. So there would have to be a 2 in one of the circles here. So if the 2 is either here or here, this could not contain a 2, not in a circle or square, so it would be 1 here. If this is the 2, we already have a 2 here, so therefore this can't be 2. If 2 is here, and this doesn't have a 2, this can't be 2. We have a 2 in the circle already, in one of the circles, in column 4. 2 cannot be here, so to avoid, we already have 2 circles in the circles and squares in columns 3 and 4. 7 and 9, therefore, cannot have a 2 in a circle or square. But the only opening now is these 2 cells. And you'd have 2 2s then in the same box, which is not allowed. So this cannot be 2 either. That's interesting. So in box 4, 2 has to be one of these 3 cells. We don't know which. In box 7, 2 has to be in one of these 3 cells. We also don't know which. Okay, I'm going to pause because I need to go bathroom. I'll be right back. This is actually, I'm getting there, so I'm getting close. So I think I'm going to try to finish it. We'll be right back. Okay, and we're back. Let's get to the stretch run. It's getting very dark, but I think we can do this. I think we can do this. Okay. Let's see. Right. In column 3, the 2 has to be one of these 2 digits here. So it's definitely in a circle. One of these 2 digits must be a 2. Right? You cannot if this were well, that could be 2. Well, okay, anyways, if this is a 2, that would eliminate 2 from 2 would have to be in a circle in column 4. So this could not be a 2 in this column. So therefore 2 would have to be here. Or if 2 is here, then 2 would have to be in one of these columns. Oh, and these can't be 2 because of the 2 that's here. Right. Where is the 2 in row 1? It has to be one of these 3. Interesting. Okay. Okay, again, 7 outside of columns 5 and 8 cannot have a 7. Sorry, there cannot be a 7 outside of a circle or square outside of columns 5 and 8. We're guaranteed 7 has to be outside of a circle or square in those two columns. Therefore, this can't be 7 here. I don't know why I had a 7 there. This could be 7, though. This could be 7. 6, we don't really have... Oh yeah, we have the same thing with 6. Outside of columns 2, 5, and 8, because 6 is not in a circle or square in any of those 3 columns, it has to be in a circle or square. So that's why this is 3, 4, 5. This cannot be 1. Okay. 8 is one of those 2. Where else can we go? Where is 9? In box 3. It has to be one of these 2 digits, which means none of these can be a 9. So one of these 2 is a 9 here. Does that tell us anything? I'm not really sure it does, but... Huh. Okay. 8 is one of these 3. 8 is one of these 3. What else do we have? Oh, this cannot be 2 and 3 added together, because if this is 2 and 3 added together, this has to be 4 and 5, and that can't be 4 and 5, because this is at most a 7. So this can never add up to 5. If this is 3 and 2 and 4 added together to add up to 6, you have the same problem. This becomes 3 and 5, and this must be 8, so that can't work. So this cannot be 2 and 4 adding up to 6. So this is 7 or 9. Interesting. If... What are the remaining digits here? It has to be 3, 4, 5, 6, 7. If... No. Okay. We know there's a 3 in column 3 in a circle or square. What else do we know? Okay. In columns, Okay. The rest of column row 8 is 2 through 7, right? This can't be 2. It's 3 through 7 here. This is 2 through 7 here. Again, 7 cannot be outside of columns 2, 5, or 8. Outside of a circle or square outside of columns 2, 5, and 8. So this can't be 7. I think the same thing with 6 also, right? Yeah. 6 cannot be... Bingo. Okay. 6 cannot be out... 6 cannot be outside of a square or circle outside of columns 2, 5, and 8. We're guaranteed that. So this can't be 6, and this can't be 6. We have a 2, 3, 4, 5 quadruplet in row 8, which eliminates 2, 3, 4, 5 in the rest of the row. This can't be 3, 4, 5. It's 6 or 7. This can't be 3, 4, 5. It's 6 or 7. That means this must be 2 or 3, and this has to be 8 or 9 here. We're guaranteed that. Because this is 2 and 6 at minimum, and it could be 2, 7, or 3, 6, or whatever, right? 2 was one of these two. What else do we know? This is a 6, 7, 6, 7 pair. Let's say this is 2. If this were 2, that would guarantee this is 3. This would have to be a 9. But in box 3, where would the 9 be? It has to be in a circle, so it would have to be here because it can't be here because this doesn't add up to 9. But we have a 9 in both of those places. Therefore, this cannot be 2. Does that tell us anything? Not particularly. Okay, if this was 3, that means this is guaranteed to be 6. This is 9, so this can't be 9. Okay, well, actually, what happens if this is 9? If this is 9, that makes this 8, which makes this 6 and 2. This can't be 2 here. Therefore, there's a 2 in one of these two cells here. So this is 2. That seems okay. Yeah, that seems okay. 2 would have to be one of these two here. Which would mean this is not 2, so this would be 2. This would have to be 3 and 4. So this would be 7. Okay. That's interesting, yeah. So this would be 2, this would be 3, 4, that would be 7. This could not be 7, so this could not be 8 here, which means 8 would have to be here. Huh. So then 8 would have to be one of these two. That looks okay so far. This can't be 7, so this couldn't be 6. That's interesting. Obviously this can't be 7. This can't be 7. Ah, where is the 7 in... We know... Actually, that's not true. This can't be 2. This can't be 3 or 4. This is a 3-4 pair, because otherwise it doesn't add up to anything. So that's 7. This can't be 2. Hmm. Okay, hold up. I, I think going down this path is not a good path. Let's look at... Okay, so this still has to be 8 or 9. Okay, so then we have... That can't be 2, right? Now we can start looking at column 6 also, because we have it filled out except for 2 spaces where they cannot... Where they could potentially not be part of a circle or square. So we still have one left here. The 2 obviously is done there. This is 1. This is 1. I guess this could be 1 too. So that's also a possibility. Maybe just make these all pink. So in column... So now we're looking at 3s. Where can 3s be? 3, you can only have 3 3s in a circle or square, right? We know we have a 3 guaranteed in column 3. In column 1, we have 1 space open. In column 4, we have 2 spaces open. In column 6, we have 2 spaces open, both in row 5 and 8. Same with column 7 and column 9. We're guaranteed a 3 in column 3. And we only have 3 rows where 3 can be out of the remaining 5 columns. So we can only have... So we're guaranteed 2 3s in those 5 rows in circles. So this must be a 3 here. If this is not 3, the problem is... Say this was a 3. If this was the 3, you don't have... That eliminates... 3 has to be either here, here, or here for columns 1, 6, and 9, or 7. It could be any of those 4. But the problem is it can only be one of those for those 4 columns. Everything else has to be a circle or a square. So this must be a 3 here to satisfy it, right? Therefore, you cannot have a 3 in the rest of this row, column, or box. So this can't be 3. This can't be 3. Since this can't be 3, this can't be 4. This is 5, 6, 7, or 8 to add up to 4, 5, 6, and 7. This still could be 3 and 5. Okay, this could be 3 and 4, I guess, which would make that 2 and 5. That's possible. 2 is one of those 2. 3 must be one of these 2 digits. If it's not, that means, again, same thing. There can only be 1 3 in row 8 for columns 1, 6, 7, and 9. So there's only 1 3. That means available. The only open space that's not a row, circle, or square is row 8 for all of them. So therefore, you have 3 other 3s in a circle or square, but we already have a 4th one here. So that does not work. So 3 has to be one of these 2 digits here, which means this cannot be 3 and this cannot be 3. Do we look at 4, 5s, and 6? Do we look at 4s? Does that help? Maybe? How many circles do we have left? Is maybe the better way of looking at it from here. In these columns. Circles and squares, sorry. Because right. We have 1, 2, 3, 4, 5, 6. This is 8. It's 14. So we have 6 here in column 1. 8 in column 3. 1, 2, 3, 4, 5, 6. Do I want to count those? Oh, maybe. I think so. Yeah, let's do we count those or not? I guess so. Right. Yeah, let's count them. Okay, so we have 1, 2, 3, 4, 5, 6, 8 here. So 6, 8, 14. 1, 2, 3, 4, 5, 6, 7. Does that make sense with the 1, though? 8 makes sense. I don't think counting the 1s makes sense. Unless I remove that anyways. Okay, let's just count non-1s. So 6 here in column 1, 8 in column 3, 2, 3, 4, 5, 6 in column 4. So that's 20. 1, 2, 3, 4, 5 in column 6. Okay. Yeah. So again, 6, 8, 14 plus 6, which is 20. 1, 2, 3, 4, 5, 25. 1, 2, 3, 4, 5, 6, 31. 1, 2, 3, 4, 5, 6, 7, 8 in column 9. So it's 39. Oh, but without the 1. 38. We have 38 circles and squares in 6 columns. 38. I guess we should count everything else, right? So aside from the okay. Actually, yeah. It should be 44 in those 6 columns, right? Because we have all the other columns, 2, 5, and 8, already set. So in those 6 columns, how many open spaces are left? One of these is a 2. Okay, in column 3, we have a 2, a 3, a 4, a 5, and a 6 already in circles or squares. We only have one more 2 available. That's not in column 1. It's going to be in columns 4, 7, or 9. In column 4, we don't have a 3. We have a 3 in column... Okay, again, we have 44 essentially left. 44 in 6 columns. That's not true. We have 44 minus 6. That's 38 in 6 columns. We have... Okay, 38 circles and squares in 6 columns. Not counting columns 2, 5, and 8. Well, that's the reason why there are. How many spaces do we need in those 6 columns? 2 requires 1, 2, 3, 4. Yes, it requires 4 spaces. 2 requires 4 spaces in those 6 columns. 3 requires 3 spaces in those 6 columns. 4 requires 2 spaces, and 5 requires 1 space. That's not in a circle or square. That's 10. I think that's already accounted for, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so those are the 10 accounted for. Five can only be accounted for once. And it has to be in row 8. Because it's 2, 3, 4, and 5. 2 is accounted for twice already. We need 2 more, so one of those is a 2. 3 is accounted for 3 times in this this set in row 8. So 5 has to be one of these. Therefore, this cannot be 5 in the rest of row 5. Because the 5 has to avoid... It's specifically not in one cell in columns 1, 3, 4, 6, 7, 9. And it can only be in row 8 because this is a 2, 3, 4, 5 quintuplet. So this cannot be 4. This is 5 or 6. This cannot be 4. It's 5 or 6. This is 2 or 4. To add up to 7 or 9, to add up to 7, it's 2 and 5, and it cannot be 4 and 3. Because if it's 2, 4, and 3, that would eliminate all possibilities for this cell. If it's 9, it's 2 and 7 or 4 and 5. And that's possible. This is a 5, 6 pair here. So we have 2, 3, 4 outside of the circles and squares. We have a 2, 3, 4 triplets in box 5 then. Which eliminates 2, 3, and 4 in the rest of the box. So this is 5 through 9 without a 6, without an 8. 5 through 9 without an 8. 5 through 9 without an 8. Okay. What does that tell us? Does that tell us anything? I'm not sure. If this is 5, this is 2, 3, that must be 4, 5. That must be a 9. Okay. That doesn't tell us much. We know 5 is one of these 3. 3 cannot be here. Okay. Ah, we have a 4, 5, 6, 7 quadruplet in column 5, which eliminates 4, 5, 6, 7 in the rest of the column. This can't be 4. This can't be 4, 5, 6, or 7, so this is 2 or 3. Where is the 4 in box 5? It has to be one of these 2 digits, which means this cannot be 4. This is 2 or 3. That forms a 2, 3, 2, 3 pair in column 7. Therefore, the rest of that column must be 4 through 9. This can't be 9, though. This can't be 9. So this is 4 through 9. This can't be 8. This is 4 through 9. Okay. Hmm. 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 Uh, hmm. This could be 3, 4, 5, 6, 7, 9 here. Hmm. Uh... Hmm. Wow, I thought this would finish up fast, but it's not. Hmm. Okay. What happens if this is 4? If this is 4, this is 3, this is 2. That means this is 5. This has to be 4 and 5 to add up to 9 at most. So this is 9. These can't be 9. Therefore, this would be 9. This can't be 5. So 5 is here, 5 is here. This can't be... One of these 2 is a 5. This 3 eliminates 3 here, so this is 2, which makes this 3. This is 3 and 6, so this must be 9. That means this can't be 9, so 9 has to be here. That seems to work okay. This cannot be 4 or 5. This 2 eliminates 2 here, so this is 3. These can't be 5 again. So 4 has to be one of those two. This can't be 3. This can't be 3. This can't be 6. This can't be... this has to be a 2 here. Which means this has to be 2. So far, it's looking fine. This is 4, 6, or 7. So this can... okay, so then if that's 5, this can't be 5. Cannot be 5. This can't be 4 then, to add up with 1 to add up to 5. This is 6 or 7, so this must be 7 or 8. We have a 6-7 pair, which would force us to be 4. So 4 and 5 could not be either of these. This would be 3 or 6. So far, it's looking okay. We have 2, 6, and 7 here. This has to be... this can't be 9 or 5. This becomes a 6-7 pair. This can't be 5. Huh. This can't be 5. 9 is here, so this can't be 9. So this must be 9 here, which means this can't be 9. So this must be 9 here. Okay. So far, it's looking fine. This can't be 3. This can't be 2. We have 3, 4, 5. This can't be 6. What do we have left in row 1? It can't be 7 here, so this must be 7 here. This, that's not true, actually. It could be 7 here. This can't be 9, though. We have 3, 4, and 5 remaining in row 1. That's fine. This 6 eliminates 6 here, so this is 7, which means this can't be 7. This is 6, which forces this to be 7. That's 7. 7 cannot be any of these 3, so this must be 7 here. We have a 4, 5, 6 triplet, which eliminates 4, 5, and 6 in the rest of the row. This can't be 7. Therefore, or sorry, rest of the box. This has to be 3. So this cannot be 3. This can't be 3. This becomes a 3, 6 pair. That forces this to be 8. 8 can be either of these. This can't be 7. This can't be 7 or 9. So far, it's looking okay. This obviously can't be 7. This can't be 3. This is looking fine. This cannot be 4 and 5 because that would eliminate all possibilities for that cell. Not sure how much that helps us. 2. Well, one of these is 2. That's not helpful. 8 cannot be here anymore. So where is the 8 in row 4? It has to be one of these 2. Therefore, this can't be 8. This is 4, 6. So far, this is still looking kosher. Maybe this is not the path to go down. Okay, let's see. No, we want those. Okay. What happens if this is 7? If this is 7, this is 2. This becomes 3 and 4. Therefore, this would be 7. This would be 9. This would be 6. 9 would have to be here. This would be a 5, 6 pair, which eliminates 5 and 4 from here. This would then be 3. This would have to be 7. This would be 2. This 6 would not mean that can't be 6, so this is 7. This is 9. So far, okay, this can't be 9, so this is 9. None of these can be 7, so this can't be 8, which forces this to be 8. That's interesting. So far, they've both made this 8, essentially. 7 cannot be either of these. We have a 4, 5, 6, 7 quadruplet in box 3. That eliminates 4, 5, 6, 7 in the rest of the box. So this must be a 2, 3 pair. This can't be 2. This 2 eliminates 2 here, so this is a 3. This cannot be 3. This cannot be 3. One of these 3 is a 4, because this cannot be 4, so this cannot be 4 here. Obviously, 7 cannot be either of these. This can't be 3, so this can't be 3. Neither can this be 3. This 3 eliminates 3 here, so this is 2. That means neither of these can be 2. So this can't be 2. Whereas the 2 in column 3, it has to be here. So this is 2. Which means 2 cannot be here. 2 was one of these 2. So obviously 2 can't be here. 2 can't be here, which forces this to be a 2. Because 2 can't be here or here. It cannot be here, so it must be here. So this is 3. Obviously, this can't be 9. This can't be 7. This is looking fine. 4, 5, 6, 7 here. 4, 5, 6, 7. Where can the 7 be in row 1? It can only be one of those two, so this can't be 7. Which means the 7 has to be in row 2, has to be one of these 3 cells. So this can't be 7. Since this can't be 7, this can't be 6 to add up to that digit. We have 3 is one of these two. We have a 4, 5, 6, 7 quadruplet in, so this must be a 3, 9 pair. This can't be 3. This can't be 3, so this must be 9, which makes that 3. 3 can no longer be here or here. This can't be 3, so this must be a 3 here. That means 3 is one of these two digits here. We're not sure which. Okay. This is still... This is looking also fine. This 6 eliminates 6 here. So this is a 4, 5 pair, which eliminates 4 and 5 in the rest of the box. This can't be 4, 5, so this must be 6. That leaves this as a 4, 5 pair. That's okay so far. Where can 8 be in column 3? Can't be here. Can't be any of these. So this must be 8 here. That forces 7 to be here. We have a 5, 6, 5, 6 pair. That forces this to be 4 and 4. That means this can't be 4. This is 5. This can't be 5. This is 6, which makes this a 5. And we have a contradiction. Oh, Dang, that was a pretty long way to get a contradiction. And that was assuming this was a 7 in row 6, column 5. That was a long way to get contradiction. Ugh. What happens if this is... So therefore, this is guaranteed to be a 5. So 5 cannot be here, cannot be here, cannot be here. That's interesting. We have a 6, 7, 9 triplet in column 6, which eliminates 6, 7, and 9 in the rest of the column. This can't be 6, 7, or 9. This is 3, 4, 5. That means 5 has to be one of these two. 5 is here, so 5 cannot be here. So this can't be 6 here. Six in column 6 has to be one of these two cells, so this can't be 6 here. That means this digit is the same as this. Guaranteed. Right? This digit cannot be either of these two, so it must be here. Well, if this were 7, which makes this 2, this would have to be 7. And it's 3 and 4. But where's the 7 in box 5? It would have to be here. And therefore we have a contradiction. So this cannot be 7. This has to be a 9, which forces this to be 9. So this is 4. So that guarantees this is a 4. Okay. So this is 9. This has to be 3 and 2, which forces this to be 5. So this cannot be 4, 5. This is 6 or 7. 4 has to be one of these two. This 4 and 5, this means this can't be 9. So that's why, yeah, when we were going down the other path, it was basically running, I was running in circles. So I couldn't, yeah, it was or not running in circles. It was basically not coming to a contradiction because this is the path. So this is, cannot be 9, cannot be 9. This can't be 9, and this can't be 9 here. These can't be 3 anymore. This 2 eliminates 2 here, so this is a 3. 3 eliminates 3 here, so that's 2, which means this can't be 2. This is 3, so this must be 3 and 6 adding up to 9. This 6 eliminates 6 here, so this is 7. 7 cannot be either of these. This is 4 and 6 adding up to that digit, but it cannot be 4 or 6. Sorry, cannot be 5. That 4 and 6 with 1 adds up to 5 or 7. So this can't be 8, but it can't be 5 either, so this must be 7. Which means none of these can be 7. We have a 4, 5, 6 triplet, which eliminates 4, 5, and 6 in the rest of the box. Therefore, this can't be 4, 5, 6, or 7, which makes this a 9. So this cannot be 9 here. This 7 with 1 must add up to 6. So that's 6 and 4. This can't be 6. This is 7. 7 cannot be either of these two and cannot be either of these two. Where is the 7 in row 2 then? It has to be here. Where is the 8 then? In row 3. It has to be here. So this is 8. This cannot be 4 or 5. This is 3 or 6, which makes this 3 or 6. This is 3, 6, or 9 here. 3, 6, or 9 here. Where is the 9 in row 4? Cannot be any of these cells, can't be here, so it must be here. So this cannot be 9 here, which forces this to be a 9. That leaves in row 1, or in box 1, a 4, 5 pair. This is 4, 5, this is 4, 5. That leaves these two digits as a 2, 3 pair. These can't be 7. This can't be 7 or 9. Whereas the 8 in box 4, it must be one of these, so this cannot be 8. Whereas the 8 in column, or row 4, it has to be here. Because it must be in a circle. Same with box 9. It has to be one of those two digits. Okay, 7 cannot be here. And 7 cannot be here. In column 3. That means this can't be 6 to add up to, with 1 to add up to that digit. Whew. The remaining digits in column 4 are 2 and 6. This can't be 3. This can't be 6 because of the 3, 6 already in box 9. This can't be 6 either. So one of these is a 6. This can't be 3. We need a 2 in row 8. It has to be here. That means this can't be 2 here. This is 3. This is 2. That's 3 in the corner. We celebrate because we know we're getting close to solving this. This is a 4-5 pair. We have a 4-5, 4-5 pair in column 1, which eliminates 4 and 5 in the rest of the column. That leaves the remaining digits as 3, 6, 7, 8. 3, 6, 7, 8, 3, 6, 7, 8. This can't be 7, though, because of the 7 in the box. Okay. Remaining digits in... This can't be 5 because of the 5 in the row. This can't be 5 because of the 5 in the row. This can't be 2. We don't know whether 2 is here or here. Okay. What is this digit? What can this digit be? It could be 2, 3, no 1. Could be 4, no 5. 6, no 7, or 8. Okay, what could this digit be? It could be no 1, 2, no 3, 4, 5, 6, no 7 with 8. Okay. This digit is the same as that, so it must be one of these two. Okay. That's fine. This can't be 3 because... Actually, none of these can be 3 because of the 3 in the row. Remaining digits. So we have everything else except for column 8 and column 9. Column 8 has to be what? 4, 5... 3, 4, 5, 7. Okay. Well, 3 cannot be either of these cells. Whereas the 3 in column 8, it has to be here. So this is 3, which means this can't be 3. This is 6, which makes that 6. This can't be 6, so this is 3. This can't be 3 or 6. It's 4, 5. This 6 eliminates 6 here, so this is 5, which makes that 6. This can't be 6 anymore, so that's a 4. This can't be 4 or 6. This 6 eliminates 6 here, so that's 7, which makes that 6. 6 cannot be any of these. 3 can't be here, so this must be 8. 8 can no longer be any of these cells. Where is the 8 in box 7? It must be here. So this can't be 8 again. This 5 eliminates 5 here, so this is 4. That leaves a 5-8 pair in row 4. These can't be 4. It's a 2-3 pair. We need a 2 somewhere in column 3, so this has to be a 2. So this is 2, which makes that 3. That leaves this digit as a 7. This can't be 3 because of the 3 in the column. We have a 6, 7, 6, 7 pair. Actually, this can't be 4 or 6. This can't be 4 or 6 or 3. So this is a 2, 5 pair. This 5 eliminates 5 here, so this must be 4, which makes this 5. That means this can't be 5, so that's 4, which means that can't be 4, so it's 5, which makes this a 4. We have in column 3, only digit remaining is a 3. So this is 3, which means this is 1 and 2 adding up. That makes this not 2. This can't be 2. This is 6, which makes this 2. This 2 eliminates 2 here, so it's 5. This 6 eliminates 6 here, so it's 7, which makes this a 6. This can't be 4. And this can't be 4 or 7, so this is 5. This can't be 5, so this is 8. This can't be 5. It's 4 or 7. This is 4 or 7, but it can't be 7 because of the 7 in the column. So this is 4. This is 7. This 5 eliminates 5 here, so that's 4. Neither of these can be... This can't be 4 or 6. So this is a 5, which makes this a 6. This 5 eliminates 5 here, and we have an 8 and a 5. Woo! That was definitely very hard. I thought I had it like about 1 hour and a half in, and it just kept going. That was very hairy, very hairy. And we went down paths where it wasn't leading to a contradiction. So, very interesting, I will say. It was very interesting to try to solve this because all sort of the little nuances of the way that it was structured contributed to the puzzle. You had to go through every little small part, right? I probably could have come up with this quicker if I had seen obviously the row 4, right, with the digits only having one digit, possibly not in a circle. That makes things much easier. And then from there, what was the thing that it was basically the columns. But that's hard to see. That's just so difficult to see that you have all the circles only in certain positions, right? And only certain spaces could not, certain rows specifically could not have a circle or a square in those 5 or 6 rows. It was basically 5 was very important, and then the 6 became important after we got the 2s and the 1s available. Whew, that was a doozy. Anyways, if you stuck through it all, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.